आइए आज बात करते हैं प्रॉब्लम्स ऑन करंट इलेक्ट्रिसिटी। सो आपके पास जो असाइनमेंट है उसमें क्वेश्चन नंबर 1 से शुरू करिए। क्वेश्चन नंबर 1 goes like this: a wire of resistance of 0.5 ohm per meter is bent into a circle of radius 1 meter. The same wire is connected across the diameter AB as shown in figure. The equivalent resistance is in ohms. So question number 1, एक वायर को एक सर्कल में बेंड किया हुआ है जिसका रेडियस 1 मीटर है, एंड देन इसी वायर को सर्कल के डायमीटर में भी लगाया हुआ है। रेडियस दे रखा है इसका 1 मीटर एंड दे रखा है कि वायर का रेजिस्टेंस पर यूनिट लेंथ 0.5 ओम, दैट इज हाफ ओम पर मीटर है। सो इस सिचुएशन में if these are the terminals A and B, you have 3 sections of the wire in parallel. Length of upper section is half of the circumference of the circle. Half circumference means pi into radius, and radius of the circle is 1 meter. So this becomes pi meters. Similarly, this is also pi meters, pi into 1 meter, and this length will be diameter of the circle, that is 2 meters. So resistance of these 3 sections will be pi into 1 meter times half ohm per meter. Here also half ohm per meter, here also half ohm per meter. So this will make it to pi by 2 ohms in all. This is also pi by 2 ohms in all, and then middle one is 1 ohm, 2 meter and half ohm per meter, that is 1 ohm. So we have got 3 resistances in parallel. So for this particular circuit, the equivalent resistance is parallel combination of these 3 resistances. That is, parallel combination के लिए 1 upon R, इसको reciprocate करिए 2 upon pi plus 1 का reciprocal 1, and then again 2 upon pi. That will make it 4 upon pi plus 1. These two will add, and that is basically 4 plus pi upon pi. So equivalent resistance of this network between terminals A and B is pi upon 4 plus pi. Let us look for the answer. The answer is D, pi upon 4 plus pi ohms. Now question number 2. The language of the question goes like this: in the figure shown, all the bulbs are identical. Which bulb or bulbs light or lights most brightly? Now, in a circuit connected in any particular configuration, any element will have power depending on current flowing through it and its resistance. Here all bulbs are identical. So all the elements are having identical resistances. Now we have one bulb here. This bulb is bulb 5, and then one more bulb here. This bulb is B1, and then 2 bulbs here, 1 bulb here. These are bulb 2, bulb 3, and this is bulb 4, and then connected like this. Now whatever current this battery delivers, that entire current passes through bulb 1, and same current passes through bulb 5. So bulb 1 and 5 will have same brightness, but since that current will divide here into 2 parallel combinations, current flowing through these bulbs will be lesser than this value. If this is I, this will be some I, and this is I minus small I. So both of these currents will be less than capital I. These bulbs are all having same resistances. So power dissipated in bulb 1 and bulb 5 will be identical, and this will be the maximum power. So answer is 1 and 5. That is again D. Now let us talk about question number 3. The language of question number 3 goes like this. Resistances of 6 ohm each are connected in a manner shown in figure. What are the currents? 0.5 ampere, with the current 0.5 ampere as shown in figure. The potential difference Vp minus Vq is. Now, the circuit is like this. You have first of all 3 resistances of 6 ohm each connected in parallel combination. This is 6, 6 and 6 ohms. Then we have 2 resistances of 6 ohm connected in series and one in parallel with this 6 ohm, and that completes the circuit. So this entire will become 12 ohm actually. The 2 resistances are in series, and then this 12 ohm is in parallel with 6 ohm. When 2 resistances are in parallel, you can solve it like this. 12 into 6 divided by 12 plus 6, 18. Actually for parallel combination it is R1 R2 upon R1 plus R2. So this will amount to 4 ohms actually. So this entire resistance combination, this represents 4 ohm resistance. Now here there are 3 resistances in parallel. 1 upon R is 1 upon 6 plus 1 upon 6 plus 1 upon 6, that is 3 upon 6, that is 1 upon 2. So R is 2 ohms. That means this entire combination represents 2 ohm, and this circuit then containing 0.5 ampere of current. So if you modify this circuit will reduce to total 6 ohm resistances in series, 2 ohm here, 4 ohm here. So from here to here it will be in all a 6 ohm resistance like this, bearing a current of 0.5 ampere. This end is P, this end is Q. So across PQ we have a total resistance of 6 ohm, and when 0.5 ampere of current is passing through this 6 ohm resistance, the potential difference Vp minus Vq. Now mind it, ध्यान दिए, किसी भी सर्किट में किसी भी पॉइंट A से B तक का पोटेंशियल ड्रॉप Va माइनस Vb देता है. सो P से Q तक का पोटेंशियल डिफरेंस आपको चाहिए Vp माइनस Vq, तो आपको P से Q तक पोटेंशियल ड्रॉप चाहिए. When you travel in the direction of current, there is a potential drop. So here that potential drop is 0.5 ampere into 6 ohm IR. So this will amount to actually 3 volts. Therefore, potential difference between point P and Q, with P higher than Q because current is flowing from P to Q. So potential of P is higher than Q, and that amounts to 3.0 volts. So answer is C. Now question number 4. Question number 4 goes like this. There is a circuit given in the figure having 4 resistances as shown. It is 2 ohm resistance and then 3 ohm resistance. Similarly, lower half mein it is 3 ohm resistance and then 2 ohm resistance, and then a current of 2 ampere is entering here. Now the upper point is point A, lower point is point B, and the question says a current of 2 ampere flows in a system of conductors shown in figure. The potential difference Va minus Vb has to be found out. Now in this system, the resistance in upper branch is 2 ohm and 3 ohm in series, so that is 5 ohm. Similarly in lower branch, Again the two resistances are in series. So resistances 5 ohm, and then since these two resistances are exactly identical and they are in parallel, so this current of 2 ampere will divide into these two resistances following the parallel law. When both the resistances are equal, the current will divide half in both. So this branch will have 1 ampere current flowing like this, and this branch will also have 1 ampere current flowing like this, and maybe here it will add to 2 ampere again. Now in a circuit, if you want to calculate potential difference VA minus VB, you are interested in finding out VA minus VB, then you have to find out potential drop starting from A to B. So you have to follow potential drop from A to B either on this path or in this path, whatever path you choose. Suppose we are choosing this path. This point in the circuit is mentioned C. Now when you travel from A to C, you are traveling in the direction of current 1 ampere passing through 3 ohm. So since you are moving in the direction of current, there is a potential drop. And then when you are moving from C to B, you are moving opposite to current through a resistance, and therefore instead of potential drop, there is actually a potential rise. We want to calculate VA minus VB, so we have to calculate potential drop from A to B. So here there is a potential drop I into R from A to C, and from C to B it is potential rise. We want to calculate potential drop, so it is negative 1 ampere into 2 ohm. So net potential drop comes out to be 1 volt, and therefore potential drop from A to B is net 1 volt, that is VA minus VB. So our answer is B, plus 1 volts. Now let us talk about question number 5. In question number 5, again we have a diagram given, and this is basically a VI graph representing two straight lines, one at angle theta from the current axis marked at temperature T1, and the other at angle theta from potential axis again marked at a temperature T2. Now here the question goes like this: the VI graph for a conductor at a temperature T1 and T2 are shown in figure. Now T2 minus T1 is proportional to, so we want to look for the proportionality of T2 minus T1. Now see, in VI graph, slope of line gives you resistance of the conductor. So here in first graph, resistance of the conductor is slope of this line, and that is nothing but tan theta. So if we say this resistance is R1, this resistance is R2, R1 is nothing but tan theta, and we know that resistance is proportional to temperature that way. So this is basically KT1. Actually change in resistance is proportional to temperature, but when you calculate T2 minus T1, that difference will be cancelled. Similarly, if you write R2, R2 will become tan of this angle, which is basically pi by 2 minus theta. So tan of pi by 2 minus theta, that is cot theta, and that is again proportional to temperature, so you can write it to be KT2. Now if you want to write T2 minus T1, from this calculation T2 minus T1 is proportional to cot theta minus tan theta. Now let us solve this proportionality. Cot theta minus tan theta is cos theta upon sin theta minus sin theta upon cos theta. that will make it cos square theta minus sin square theta divided by sin theta into cos theta, and then this will become 2 cos 2 theta divided by sin 2 theta. Actually we have multiplied 2 up and down. 2 sin theta cos theta will become sin 2 theta, and that is basically cot 2 theta, since we were talking about proportionality, and therefore T2 minus T1 will become proportional to cot 2 theta. If you have any doubt about in your mind about this proportionality, actually R is R naught plus alpha R naught delta theta. Alpha is the temperature coefficient, or you can say delta R is proportional to R alpha delta theta, that is proportional to delta theta. So when you calculate delta theta for this delta R, automatically that R naught will be cancelled and you need not worry about that. So this was question number 2, T2 minus, sorry, this is question number 5, T2 minus T1 is proportional to cot 2 theta. This 2 is a constant, will move out of the proportionality. And then the answer of this question is C. Now let us talk about question number 6. Now question number 6 says the two wires A and B of the same material having radii in the ratio 1:2. Now you understand, when radius is in the ratio 1:2, the area is in the ratio 1:4 and carry currents in the ratio 4:1. The ratio of drift speed of the electrons in A and B. Now drift speed Vd. Vd is I upon NEA. This is a relation of current and drift velocity. We have already studied this. Then Vd in A divided by Vd in B is Ia upon Ib into AB upon AA. It is directly proportional to I and inversely proportional to area. Area means, actually area of cross section is proportional to radius square. So this can be written as RB square upon RA square. Now pi r square होता है, basically pi r square में pi cancel हो जाएगा. Now Ia by Ib is given the currents in the ratio 4:1, so that is 4 by 1, and radii in the ratio 1:2. 1 is down, Ra is down, Rb is up, so this will become 1:2, and that is again 4 by 1 into 4 by 1, and that will finally become 16 by 1. Therefore Vda is to Vdb is 16:1. The answer comes out to be A. So this was simple. Now if we talk about question number 7. Question number 7 mein, again we have to talk about the drift velocity. 7 goes like this. A copper wire of length L and radius R has a potential V applied across it. The drift speed of the electrons is Vd. The diameter of the wire is doubled. The electron drift speed becomes. Now most of you think drift velocity is inversely proportional to area of cross section, and as diameter changes, the area of cross section changes, therefore drift velocity will change. But here the question is different. They are saying potential difference applied across the conductor is constant. So let us write the expression. Vd is I upon NEA. I is current flowing through the conductor. So I is V upon R into NEA. This is simple Ohm's law, V is equal to IR. Then R, the resistance of conductor, in terms of resistivity of the material, can be written as R is equal to rho L by A into NEA. Here A will be cancelled and we are left with V upon rho NE times L. Now see, when you connect a conductor across a constant potential difference, the drift velocity of electrons in the conductor does not depend area of cross section. Also, it depends on length of the conductor, and that is inversely proportional to length. Larger the length is, lesser will be the drift velocity. Actually, larger will be the length, larger will be the resistance, lesser will be the current, and therefore lesser will be the drift velocity. So Vd doesn't depend on area of cross section. Therefore, while doubling the diameter, the area of cross section will change. Therefore, drift velocity will not change. So answer is D. Now question number 8. For again question number 8, we have a circuit presented like this, a terminal A, then a rectangle. This rectangle is made of a copper wire, means conducting wire, and then we have 3 resistances connected like this. The resistances are 8 ohm, 12 ohm and 6 ohm, and then one terminal of the circuit is at this node, that is B. Now if you modify this circuit a little, this corner is connected to this corner through this conductor as well as this conductor. Both are creating same effect. So even if you remove this conductor, that doesn't change the properties of the circuit. And then instead of drawing B here, we can draw B here. Now, you know, a connection on the copper wire can be moved. Actually, this end is connected to this end through a conductor. So this 12 ohm resistance is actually in parallel with 6 ohm resistance. Instead of drawing it like this, we can modify this to draw like this, 12 ohms. Similarly, here to here it is connected. So instead of connecting 8 ohm here, you can connect it here, here or here. So this 8 ohm can be connected to this conductor here somewhere, and then we can modify it to like this. Now we are left with a circuit where B is this terminal and A is this terminal. So connect A directly here instead of with this big conductor. That will become this. And now it is very clear that these 3 resistances are in parallel, and therefore 1 upon R is 1 upon 8 plus 1 upon 6 plus 1 upon 12. They are in parallel. So here the LCM is 24, 3, 4 and 2. This is 9 by 24. So R will become 24 by 9 or 8 by 3. Now 8 by 3 means it is 2.66 ohms or actually 2.7 ohms. So the answer is B. Now question number 9. Question number 9 goes like this. 8 identical cells, each of EMF E and identical resistance R is equal to 1 ohm are available to us. These are connected in X parallel rows with each row containing Y cells in series. This combination is then connected across a resistor of 2 ohm resistance. The heat produced per second in the resistor will be maximum when? Now here we are trying to make a battery which is made of the combination of 8 resistances Now, if there are Y cells in series, you will have cells connected like this and Y cells in series. So, each series combination will behave like a single cell whose EMF will become YE and internal resistance become Y into 1 ohm, because each battery has an internal resistance of 1 ohm. And then suppose we have X cells in parallel. So like this, if we have X cells in parallel, each having Y into 1 ohm internal resistance and YE EMF of the cell, this will convert into a single cell of EMF YE, because parallel में EMF same रहता है, and internal resistance will become Y ohms X times parallel, so that will become Y into 1 ohm X times parallel, and then you connect this battery to an external resistance of 2 ohm. Now there comes in picture the maximum power theorem. The power delivered to external resistance is maximum when external resistance is same as internal resistance of the battery. So external resistance is 2 ohm. Internal resistance of this combination or battery is Y into 1 by X. So this will become 2 is equal to Y into 1 by X. So if you solve it, you get Y is equal to 2X. And since we have in all 8 cells, therefore Y cells in series and then X times parallel will make it basically Y into X is equal to 8. So we have two equations to satisfy. Y into X, X is Y by 2, that will make it 8. So Y is 16 ka square root, Y is 4. When Y is 4, X becomes Y by 2, so X becomes 2. So our answers are Y is equal to 4 and X is equal to 2, that is C. So this was question number 9. And then question number 10. A steady current flows in a metallic conductor of non-uniform cross section. Question number 10 देखिए, a constant current, steady current is flowing through a conductor of non-uniform cross section. That means the conductor is such that its cross section varies, maybe somewhat like this. Now here, when cross section changes, what quantities change? They say, then which of the following quantities is constant along the conductor? Now let us examine. First of all, A, the current. Since all elements of this conductor are in series and in series currents always remain same, therefore A is a correct choice. You may not need to examine rest of the answers, but still let us see. B is current density. Now current density J is basically I upon A. When I remains same at every cross section and A is changing, J changes. Now let us examine the answer C, electric field. From Ohm's law, vector form of Ohm's law, J is equal to sigma E. So magnitude of electric field is J by sigma. Sigma is material property, remains same everywhere, and J is changing, therefore E also changes. And finally D, the drift velocity. Drift velocity Vd is I upon NA. I is same everywhere. N is material dependent constant, that is free electron density. E is universal constant, that is electronic charge. Area of cross section changes, I remains constant, so Vd also changes. Therefore, in a non-uniform cross section wire, J, E and Vd change, but I remains same everywhere. Therefore, A is the choice. Now question number 11. Question number 11 goes like this. The A ring made of a wire of total resistance R. A and B are 2 points on the circumference such that angle ACB is equal to theta. So we have a circular wire of total resistance R, and then on its circumference we have 2 points ACB like this, and these are, let's say, terminals A and B, and center is C, and they are giving that this angle is theta. When this angle is theta, this angle becomes 2 pi minus theta. Now, total resistance of the entire circumferences are, if we consider radius of this circle to be, let's say, A, from arc length upon radius formula of the angle, this length becomes A theta, and similarly this length becomes A into 2 pi minus theta. Now let us apply unitary law to find out the resistance of the two parts. The lower part, now 2 pi A is the total circumference which has a resistance R. So the part length A theta will have a resistance R upon 2 pi A into A theta. A is cancelled and this becomes R theta upon 2 pi. Similarly, for the upper part, the resistance will become, it is A times 2 pi minus theta. So this will become R divided by 2 pi into A times 2 pi minus theta times A. A is cancelled. It is R upon 2 pi into 2 pi minus theta. Now we have two resistances. The resistance of lower part is R theta by 2 pi. This is R theta by 2 pi. And resistance of the upper part, that becomes R by 2 pi times 2 pi minus theta. And you understand, here the current will divide into two parts and that will recombine here. Therefore, these two parts are actually parallel, and for parallel combination, the equivalent resistance 1 upon R will become 1 upon R1 plus 1 upon R2, that is 2 pi by R theta, and then plus 2 pi by R, 2 pi minus theta. If you add them up, R is LCM, theta and 2 pi minus theta, that is again LCM. Now numerator 2 pi common. You add 2 pi minus theta to 2 theta. Theta cancels out and we are left with 4 pi square upon R theta times 2 pi minus theta. Therefore, the equivalent resistance R becomes, the R is R theta times 2 pi minus theta whole divided by 4 pi square. Let us match the answer for question number 11, and this matches to option D, and that is all about question number 12. So this is question number 12, and if we so question number 12 goes like this. In the network shown in figure, the ring has no resistance, that means it is made of a copper wire. The equivalent resistance between points A and B is. So question number 12 में देखिए, you have three resistances connected like this, and then one resistance here to make it to point B, and one terminal is this. Now see, this point and this point is connected through two conducting wires which have same meaning. Therefore, if you remove this, even then there will be no effect on the circuit. This is resistance R, this is 3R, this is 3R, and this is R. So here now it is quite visible that this 3R, and this 3R, they are 3 on all in parallel, because this is directly connected to this. So you can draw it like this, a 3R connected to A. Similarly, this is also connected to A directly, so you can again redraw it to connect to A. So now it is eminent that these 3R, this 3R and this 3R, they 3R in parallel, and this R is in series. 3R, 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 3 times parallel will make it 1 upon 3R, 1 upon 3R plus 1 upon 3R, and that will 3 upon 3R, that means 1 upon R. Therefore, R dash is R. These three resistance we have as a single resistance R that is in series with this R. So R plus R will make it 2R. The resistance between A and B will become 2R. Now, so the answer is B. Question number 12 के लिए it is B. Now let us talk about question number 13. Question number 13, again we have a figure. The question goes like this: the equivalent resistance between terminals A and B of the circuit consisting of 7 resistors, each of resistance R as shown in figure, is. Now here you see, it is, if you reconstruct the figure, it will be R here, and at the lower side it will be basically 2R. Then here, this side, upper side is 2R, lower side is R, and then you reach to terminal B, and in the middle of it, it is a resistance, again R. Now they want to find out equivalent resistance of this figure between terminals A and B. Here you understand that the circuit represents basically a Wheatstone bridge, and this Wheatstone bridge is not balanced. It is basically 1:2 for the upper part and 2:1 for the lower part. So upper ratio is 1:2 while the lower ratio is 2:1. So circuit is unbalanced. And in unbalanced Wheatstone bridge, you can find out equivalent resistance between the two terminals by either Kirchhoff's laws. You connect a battery, find out the equivalent current following 3 loops, etc. and so on. That is a quite longer method. And to solve a circuit in a competitive examination like IEEE, you need shorter methods. So the other way of doing it is that you go for delta to star conversion. You remember? Suppose we are trying to convert this delta into a star. So first of all, you set your star into this delta like this and find out summation of all the 3 resistances for this delta. It is R plus 2R, sum of all these 3, that will make it 4R. Now you want to calculate this resistance, you multiply these two, 2R, and then divide that with the sum of 4R. So it is R square divided by 4R will make it R by 4. Similarly, you multiply this R and 2R, that will become 2R square divided by 4R will make it R by 2. And similarly here, it is 2R and R, 2R square divided by 4R will make it again R by 2. And then you can remove these 3 resistances which we have converted into the star configuration, and then connect these to their respective terminals. Now between A and B, you remove these resistances, and between A and B, now it is simple series and parallel combination. These 2 resistances are in series, these 2 resistances are in series, and then they are in parallel. So first of all, Let us try calculating their series combination. R by 4, 2R in series, simply add. R by 4 plus 2R will make it 4 to the 8 plus 1, 9, 9R by 4. Similarly solve here. R by 2 plus R will make it 3R by 2. And then these two resistances, 9R by 4 and 3R by 2, they are in parallel. So 9R by 4 and 3R by 2 in parallel, R1 R2 divided by R1 plus R2. If you add 9 by 4 and 3R by 2, 3R by 2 means 6R by 4. 6R by 4 plus 9R by 4 will make it 15R by 4, and that will combine these two resistances in parallel. So that will become, R by 4 is cancelled, that becomes 9 into 3 divided by 15 into 2, and that finally becomes 3 5s are 15, it is 9 by 10 R. Now 9 by 10 R is resistance from here to here, and then add this R by 2 to it, because that is also in series of it. So the resistance will equate to 9 by 10 R plus R by 2 will make it 10, 9 plus 5, 14 R by 10, and that is 7 R by 5. So answer comes out to be C. Question number 13, the answer is C. Now let us talk about question number 14, and question number 14 again has the diagram containing several resistors. Let's see what the question number 14 goes like this. We have a 3 ohm resistance, then 3 resistors, 20, 30 and 60 ohms in parallel. Then we have one more set of 24 ohm and 8 ohm, they are in parallel, and finally 1 ohm in series of it to reach Y. They give a potential difference across 24 ohm to be 48 volt, which is basically the potential difference across the parallel combination of 24 and 8 ohm. So let us first of all convert this simple circuit to single resistances in series. These three are in parallel, 20, 30 and 60. So 1 by 20 plus 1 by 30 plus 1 by 60 will make it 60 in LCM, and then 3 plus 2 plus 1, that will make it 6, that is 1 by 10. Then 1 by 10 is actually 1 by R, so R will become 10 ohms. So parallel combination of 20, 30 and 60 will make it basically 10 ohms. Similarly, we have 24 and 8 ohms in parallel. 24 into 8, R1 R2 divided by R1 plus R2, 32. 8 4s are 32, 4 6 are 24. So here it will become 6 ohms. So parallel combination of 24 and 8 will become 6 ohms, and then we have 1 ohm to reach Y, and this is X. Now here across 6 ohm we are given 48 volt. Now this entire can be rearranged to give you like this. Except this 6 ohm, rest are 10 plus 3, 13 plus 1, 14 ohms are in series, and then we have 6 ohms in series with that, and suppose we write like this, because in single branch order of components doesn't matter, so we can write like this. Now out of this, across 6 ohm resistance we are given 48 volts of potential difference. Apply the division method of potential. in series, and you understand in series combination when you try to divide potential between two resistances, अगर आपको 6 ओम के क्रॉस पोटेंशियल डिफरेंस फाइंड आउट करना है तो 6 ओम ऊपर डिवाइड बाय दोनों का सम 14 plus 6 multiplied by total potential difference which we want to calculate, let's say that is V, and that comes out to be basically 48 volt across 6 ohm resistance. You solve it for V, V gives you, this is 6 plus 14, 20, means 48 into 20 divided by 6, 6 8 is 48, so V comes out to be 160 volts. So potential difference between X and Y is 160 volts. The answer is A. Now question number 15 again has a diagram, and here we will rely on the fact that in a circuit when a capacitor is charged, its behavior is different at the start of charging, and its behavior becomes different when it is completely charged. In fact, for a transient behavior, when capacitor is uncharged, when Q is 0, when capacitor is uncharged, the XL reactance offered by capacitance becomes 0, and when Q is maximum, when capacitor is fully charged, XL tends to infinite. So capacitor behaves as zero resistance when it is starting for charge, and it behaves as infinite resistance when it is completely charged. So in this particular circuit, we have a capacitor connected to a 2 volt cell, switch is made on at t is equal to 0, it is 2 volt cell, then 1000 ohm resistance, a capacitor of 1 microfarad, let us say, and in parallel with this we have again 1000 ohm resistance, and then like this. At t is equal to 0, when you switch it on, the capacitor allows the entire current to flow through itself, and therefore this resistance is short circuited because entire current flows through the capacitor. Capacitor starts behaving like zero resistance. So at t is equal to 0, the current has initial value I is equal to V by 1000 ohm, and that becomes 2 milliampere. But when you wait for a longer time, when this capacitor is fully charged, the capacitor starts behaving like open circuit. Open circuit means then the capacitor will not allow any current to pass through it, and then this resistance will come into picture, and the current will start flowing through this path, and in that case the resistance in this path will become 2000 ohm across 2 volt battery. So final value of current will become 2 volts and 2000 ohms, and that will become 1 milliampere. Therefore the initial current will start with 2 milliampere, and as time passes it will become 1 milliampere. So the answer is D. So this was question number 15. Now let us talk about question number 16. In question number 16 again we have a circuit consisting of few resistances, 3 ohm each. The question was like this: in a circuit shown in the figure, the battery of EMF 15 volt with no internal resistance, each resistance is 3 ohm, potential difference across the capacitor is. So we have to find out the potential difference across the resistor, the capacitor, in given circuit. Question number 16. Here we have 3 ohm resistance, then one more 3 ohm resistance. This is 3 ohm resistance, a capacitor, 3 ohm resistance, and then a battery of 15 volt connected to it. Now see, in steady state, इस circuit में कहीं पर कोई switch नहीं है. This circuit is connected for quite long time. In steady state, when capacitor will be fully charged, it will not allow any current to pass through this branch, and therefore rest of the circuit will behave this much only. In this circuit, you can very easily calculate currents. A simple way is that you go by Kirchhoff's laws, but that is a little longer. We can go for, since there is a single cell, we can go for simple series and parallel, and then this is 6 ohm, these 3 ohms are in series, and then that is in parallel with this 3 ohm. So the parallel combination is 6 into 3 divided by 6 plus 3, 9. That will make it 2 ohms. So this entire will behave as 2 ohm, and then this 3 ohm. So current delivered by this battery will be 2 ohm plus 3 ohm, will be across 5 ohm resistance, 15 volt battery. So current will become V by R, and that is 3 ampere. This 3 ampere current starts from the battery. When this 3 ampere current comes here, it will be divided into 2 parts. One is for 6 ohm and the other is for 3 ohm. Now current is proportional to 1 upon R. So when you find out the part of 3 ohm resistance, it will be basically, if you want to find out this current, it will be 6 divided by sum of these two, 6 plus 3 into total current 3 ampere, will make it 2 amperes. So here it is 2 ampere and rest is basically 1 ampere, because the entire is 3 ampere. They will again recombine to form once again 3 ampere. This was 1 ampere, and once you have calculated all the currents, reconnect your circuit, the branch containing capacitor, into its place. Now we want to find out potential difference across the terminals of the capacitor. So let us start from A to B and move along any path from A to B, taking potential drop positive. So if suppose we move from A to B on this path, VA minus VB will become 1 ampere through 3 ohm resistance, the potential drop is 3 volt, and then here it becomes 3 ampere passing through 3 ohm, the potential drop is 9 volt. Here no current is passing, 0 amperes, because capacitor is fully charged. So in this branch no current will pass. So our answer is 3 plus 9, that is 12 volts. So potential drop from A to B is 12 volts. So VA minus VB, or the potential difference across the capacitor, is 12 volts. The answer is C. Now question number 17. Goes like this. 17 also has a circuit to be dealt with. Here we have 3 cells, one V volts, the other is again V volts, and the other is 2 V volts. The upper branch has a resistance R, lower branch has a resistance 2R, middle branch has a capacitor, and then we have to find out the potential difference across C. The question goes like this. In the given circuit, with the steady current means transient behavior is not there. capacitor is fully charged, the potential drop across the capacitor must be. Now see, when capacitor is fully charged, you can suspend this branch as there will be no current in this branch. Then current will flow only in this path. So apply Kirchhoff's law, write down the equation. Suppose current is I into 2R plus I into R plus V minus 2V is 0. We'll make it 2IR plus IR, that is 3IR. 3IR minus V is 0. So I is equal to V by 3R. The current flowing through this loop is V by 3R. Now let us put back the branch we have removed, and that will become this. Now suppose we are interested in finding out potential difference across the capacitor. You travel from A to B following any path. So suppose we travel this way, VA minus VB is potential drop calculated along the path moving from A to B. We are traveling in the direction of current. Therefore, when you pass the resistance, there will be a potential drop IR, then plus V, then minus V, negative to positive. We have VB. This is cancelled. I is V by 3R multiplied by R will cancel, will give you V by 3. So potential difference across the plates of the capacitor is V by 3. The answer is C. That is question number 17. Now question number 18. Question number 18 goes like this. There is a conductor of the shape of a truncated cone. They have given figure also. There is a figure like this. We have a conductor in the form of a truncated cone with radius of 1 and R, and the radius of other end as R dash, and the height of the cone is H. We have made it like this. Resistivity of the material is rho, and they want to find out resistance of this conductor between the two faces. The statement of the question goes like this. A right circular cone is truncated at height H. Radius of the base is R dash and that of the top is R. Then the resistance of the truncated bottom portion is. Now here, if you are trying to calculate resistance between these two terminals, think of elements like this, and let's say radius of this element is x. So if you apply the similar triangle rule, r minus r dash divided by h is, suppose this is x and this is let's say L, so this will become dl. Now we try to calculate resistance of this element dr, that is rho L, L is dl, divided by area is pi x square. If you try calculating resistance of it, this is, we have to find out x here because integral variable hamara L hai and here the variable is x. So write it like this, r minus r dash this much divided by h is x minus r dash divided by L. So it is like this, r minus r dash by h into L plus r dash is x. Differentiate from both the sides, r minus r dash by h into dl plus 0 is dx. So we can put value of dl, it is rho upon pi, dl becomes h upon r minus r dash times dx. Now since all the elements are in series, you just integrate this r to give you entire resistance. So total resistance R will become, R is equal to rho h by pi integral of, this is dx and that multiplied by h by r minus r dash. Now times x square, h by r minus r dash we can take as common, and then it becomes dx upon x square. X is varying from r dash to r, so total resistance R becomes rho h upon pi r minus r dash. This is dx upon x square integrated to minus 1 upon x from r dash to r. If you try to adjust the negative sign in front of it, you just change the integral limits, make it r to r dash, and then it is rho h upon pi r minus r dash, and this will become 1 upon r dash minus 1 upon r. LCM लीजिए, r minus r dash will be cancelled, and then finally we are left with r is equal to rho h divided by pi, and this will become r minus r dash, that will be cancelled. So नीचे LCM सिर्फ बच जाएगा, that is r dash. So that is the resistance of truncated cone. The answer comes out to be C, rho h upon pi r dash. Now this was question number 18. Now let us talk about question number 19. Question number 19 is quite simple. The statement of the problem goes like this. There are actually 12 cells in series, and they say like this. For question number 19, there are 12 cells, each having same EMF, are connected in series with some cells wrongly connected. The arrangement is connected in series with an ammeter, and two cells which are in series, current is 3 ampere when the cells and battery aid each other, and it is 2 ampere when the cells and battery oppose each other. The number of cells wrongly connected is. Now see, if out of 12 cells you connect n cells wrongly, their EMF is not available. At the same time, they will cancel out EMF of n more cells. Therefore, you will have a battery whose EMF will become 12 minus 2n times E, but resistance will remain, of course, 12 R, if R is the internal resistance of the battery. Then you have two situations. In first situation, you have two cells helping it, that is 2E and 2R, and then some external resistance R. So current is 3 ampere. So 3 ampere current is total EMF 12 minus 2n into E plus 2E divided by R plus 14R. Similarly, if you have the opposite of it, battery is same, 12 minus 2n into E and 12R, but this cell is opposite connected. It is like this. It is 2R and 2E and then connected to external resistance. The current comes out to be 2 ampere, and this 2 ampere is 2 minus 2n into E, and the EMF of the two cells will subtract from it, that is 2E, divided by R plus 14R. Now we have two relations. In one it is 3 ampere and in the other it is 2 amperes. You divide equation number 1 to equation number 2. The denominator will be exactly cancelled and we will be left with 3 by 2 is equal to 12. E will also cancel by taking common. So it is 12 plus 2, 14 minus 2n. In the denominator it will be 12 minus 2, 10, 10 minus 2n. So 2 just you cancel, it will become 7 minus n divided by 5 minus n. Cross multiply. This will make it 15 minus 3n is equal to 14 minus 2n. So that is n is equal to 1. So actually in this particular question, one cell is wrongly connected. The answer is B. Then question number 20. The question number 20 is also quite simple. Here we have the language going like this. Two resistances 300 ohm and 400 ohm are connected in series with the battery of EMF 60 volts and negligible internal resistance. A non-ideal voltmeter reads 30 volt when connected across the 400 ohm resistance. The reading of same voltmeter across 300 ohm resistance is. So to calculate this, let us draw the diagram like this.